Take a triangle and one of its medians. It splits the triangle into two triangles. It turns out that the areas of these triangles are equal. Let's try to prove that. Let's label this segment by x and this segment by x, and let's drop this altitude in the triangle. It turns out that this altitude is actually common for both the small triangles in the picture. For this triangle, this is the altitude, and for this triangle, it is the same altitude. And so, the area of this triangle would be x times h divided by 2, and the area of this triangle would again be x times h divided by 2. And therefore, the median in any triangle always splits the triangle into two parts of equal areas. Now let's try to generalize this statement. Instead of taking the median, I'm going to take a random point on this side, and I'm going to split the triangle into two parts like this and like this. And the question is, what's the ratio between the areas of these two parts? Well, first suppose this length here is A and this length here is B. Then the area of this triangle would be the base A times the height h divided by 2. And the area of this triangle would be the base B times the height, which is the same height, h, divided by 2. And so we get these two equations, where S1 is the area of this triangle and S2 is the area of this triangle. And now when we divide this equality by this equality, we get that S1 divided by S2, which is here, equals, the h cancels out, the 2 cancels out, and what is left is A divided by B, so A divided by B. And therefore the ratio of the areas that we were looking for equals the ratio at which this point divides this side. Conversely, having this picture, we can find the ratio A divided by B if we just know the ratio of the areas of these triangles. This is the optional problem. We have a quadrilateral ABCD, and M and N are the midpoints of the sides AB and CD. We need to prove that the area of ABN equals the area of AMD plus the area of BMC. And here's the solution. To solve the problem, we're going to write the area of ABCD, the whole quadrilateral, in three different ways. For the first way, given here, split the quadrilateral along the diagonal BD. Then we get the triangle ABD and the triangle BCD, and the sum of their areas equals the area of the whole quadrilateral. So we get this equality. The second way, we're going to split the quadrilateral along the diagonal AC. And so we get triangle ABC and triangle ACD, and the sum of their areas equals the area of the whole quadrilateral ABCD. So that's given here. And the third way, actually we're going to use the red segments AN and NB to split the quadrilateral. And so we get three triangles, ABN, AND, and BNC. And the sum of these areas equals the area of the whole quadrilateral ABCD, which is given here. Now I'm going to take this equality and divide it by 2. So on the left hand side I get the area of ABCD over 2. And let's see what we get on the right hand side. The area of ABD divided by 2, see on the picture ABD, this is exactly the area of AMD, because the area of AMD equals the area of MBD, because of the median here in this triangle. And then half of the area of triangle BCD, see it on the picture here, BCD, equals the area of triangle BCN, again because of the median here. I'm going to do the same thing for the second equation. The area of ABCD divided by 2, I wrote here, equals the area of ABC divided by 2. Let's see, ABC divided by 2. This would be the area of BMC. And lastly, the area of ACD divided by 2 would be, let's see, ACD. Well, that would be A and D because of the median. Now that I got these two equalities, I can add them and get the area of ABCD, which is the sum of the two halves of the area ABCD, equals area of AMD goes here, area of BMC goes here, area of BCN goes here, and area of AND goes here. Finally, I'm going to take this equality and subtract it from this equality. Notice that the area of triangle AND cancels out here and here, and the area of triangle BNC cancels out here and here. And of course, the area of the quadrilateral ABCD cancels out. And so we're left with 0 equals the area of ABN minus the area of AMD minus the area of BMC. But you see, this is exactly what we wanted. Just put these two areas on the other side of the equation, and then we have it.